Hello, everybody. Thank you, Patrick. Hope you are doing well for this last session. So I'm going to talk about the hardware today for the display system for need-to-eye. And mainly to focus on the optical technologies, use it in the smart glasses or even in the VR devices. I'm the CTO of Optinvent. Optinvent is a company creating smart glasses display systems based on our own technology. You see in this slide there is few components based on injection molding technique, which is make them scalable, large scale, and very low cost. So here is the introduction. In summary, I will start by make some kind of classification for the optical technology for AR, VR, and then I will focus on optical technologies used today in the current product, smart glasses. I will talk also about compare the current product, the whole product, not only the technologies. I will talk also about the user interface for AR product, which is a very important piece. And then I give you our vision and future trend in AR headset and smart glasses. Finally, I give you some example of some application used today by our customers in the industrial field with the smart glasses. So here in this picture you see several types of devices. On the left, upper left is Aura2, our product, HoloLens, and the other one is from Sony. So you see the difference, the form factor are different. Some are AR, means transparent, the other not, mainly Sony. So I'd like to talk about this classification, but before that, I would like also to talk about the main components that make a main important component to produce the smart glasses. So maybe there is more than 4, but for me, these are the main technologies today. On the top left, you have the CPU, GPU. Actually, these components are used in the smartphone. Smartphone is a large surface, so you could evacuate heat. You could really use large battery. But for smart glasses, the situation is different. You have very small place. You need to have low power, but still maintaining the performance. So here the challenge is to get adequate CPU, GPU, small size, but with really very low power consumption. And the upper right is the display technology. We believe that display technology is one of the key technologies for smart devices. Here we are not in the semiconductor industry. We cannot reduce everything to micron. So optics, you cannot reduce everything to 0. This is why there is some challenging work to have higher field of view, small footprint, while containing the cost and maintaining the high brightness. I'll be back to this. Another challenge also is, since smart glasses are standalone device, you need a battery. So today, everybody are using lithium-ion battery. The capacity is around 1,000 milliamp hour. It has some size. We need this size to be down, and also we need maybe more freedom with the form factor. And finally, I think where is the big value is in the software. Today, we need optimized software. We need applications. We need also a new user interface, but it's still in an open platform because we need to allow our customer to create their use case, to allow anybody to create application on these new devices. So now, if we, I would like also to talk about the main parameter for the glasses, which is ergonomic, but it has relation with optics. So the optics, the light that, the physics that talk about visible parameter, we talk about photometric parameter. So on this slide, you see the eye in the left. You see how we create large image today. We start with a microdisplay, and then we magnify the microdisplay by a lens, right? So when you magnify this microdisplay with the lens, your eye, the perceived image is enlarged, all right? So the main parameter is what we call the eye relief, the distance between the optics and the eye. Today, if you look to my lenses, the eye relief, the distance between the lens and my eye is about 15 millimeter. So for some system, today the distance is between 15 and 20 millimeter. The other parameter is what we call the eye box in green. What the eye box is when you wear the glasses, you have a kind of rectangle. Your pupil is inside. You should see the image. So you have people, don't have the same interpupillary distance. So if the eye box is too small, you cannot see the whole image, or you have to adjust every time. So as an ergonomic parameter, you need to have very large box. Today, it's about 10 by 10 millimeter. And that way, you cover 99% of the population. When everybody wear the glasses, even a child, he will see the image all the time. So why I'm talking about this? Because these two parameters are the main parameter that determine the size of the optics and the performance of the system. The other parameters also is the brightness. So the brightness today, if you have a mobile device like smart glasses, if you are outside, you need at least 3,000 to 5,000 nits. Where today all the products, for example, our product is 3,000, but other product is 500. 500, you cannot see, you cannot display decent image in daylight. You have also, you need to have what we call decent field of view. Field of view means how big the image. So this depends a lot on the application. For some information application, you don't need very large field of view. However, for surgical, for some 3D, you need larger field of view. The trend today is to have larger field of view. And the other parameter also is what we call the image position, at what distance you locate the image. So normally, in current product, the image is located at 3-4 meters. This could be okay for some application. However, from other application, you need to be close or far away, okay? Flip view, what flip view? Flip view is the way, if you have a glasses, you don't need all time the image in front of you. You could flip it up or down. This helps a lot on the ergonomy. If you consider binocular system, there is also one ergonomic parameter that is the convergence, means at what distance your eye converge. If you converge at 50 centimeter or far away. This is, if you don't optimize this parameter, this creates strain, and people couldn't support the glasses during long time. And finally, this is also basic ergonomic parameter, the light, the weight. I think the weight should be less than 100 grams. Today, you see some product, the weight is more than 1 kilogram, which is not acceptable. You need also to allow people to wear their glasses or to have their ophthalmic correction, because 50% of population, they have correction in their eye. So all these parameters have their importance on designing the display function. So now I'm going to give you some classification quickly. For VR, of course, VR is not transparent. So on the right, you have the optical system. For example, if you consider Sony, the field of view is very large. And what's important for any virtual image is what we call the number of pixels per degree. So the eye resolution is about 60 pixels per degree. It means if you display larger pixel per degree, your eye couldn't resolve it. However, if you display very few pixels like Oculus, okay, you see the pixel, and this is not good for the resolution. So for each display, it's very important to notice the number of pixels per degree. The optical system is very simple, means you have molded lenses and a micro display, and generally speaking, you correct the distortion by software. If you consider Oculus, they have 110 degree and only 12 pixels per degree, which is very, very low. And in that case, they don't have micro display, they have the smartphone directly that manage the content. So in summary, VR systems, the value is on the software. The value is how to correct the, to have low latency and not on the optics. The optical system is low cost and the quality is very low. Now, the other system, we call them see-around. It means these systems are not transparent. However, you could still see around them, like Vuzix M100 or 200, Recon Jet. So these systems are still small. Could be used in warehouse, but you cannot do true AR application with them. The optical system is very classic. You have folded mirror with a lens, and the field of view is too small, because if the field of view is too large, the system becomes very cumbersome in front of the eye. And it has low barrier to entry. Anybody could do a design. Any student in optics can design this. You have now the system, what we call the true AR. The first system are using free air propagation. You see the eye position, and you have a 45-degree folded mirror, so you have a referral system, like what Vuzix is doing, or ODG. So this system still cumbersome. They still have big volume in front of the eye, and they are, the efficiency is low because you have a different path. You cross several times the semi-reflective mirror, and also there is low barrier to entry for the optics, and sometimes it's subject to dust deposition and also to a lot of ghost image, right? So it works, but I don't think people would like to have these big things in front of their eyes. Now the other system that have more interest today, we call them light guide based. What that means? It means the optical system, the collimation system is on near the temple, and in front of the eye, you have. Sorry, I don't have pointer. You have what we call a light guide. So this light guide is transparent. And the light guide function is to transport the magnified image from the temple to the eye, okay? And here, several technology, you could see several technologies. So on the left, you have what we call diffractive technique. It's used by Sony and HoloLens. So what diffractive technique is they are using a diffraction element. It's submicron, 150 nanometers. So the light is coupling in by a diffraction pattern, and then also extracted from the light guide. Thank you. Extracted from the light guide. Where is it? Okay. Extracted here, injected here. So the advantage of this system, you could have high transparency, like 85%. The problem with this technique, any diffraction technique is very sensitive to the wavelength, especially to the field of view. Larger is the field of view, larger is the spectrum, and you got color issue, okay? So they try to correct the color issue, but they still limit it. This is why this technique today used by Sony in monochrome, only green, or with micro lenses limited to 30 degree. So the other technique, we call it polarized technique. It uses this reflector, embedded reflector. So this light guide is made by several parts. Actually, they are using wafer. With each wafer has 30 to 40 layers, high temperature process. They glue them together. It should be aligned, and they cut it here. They polish it, so the yield is low. The cost is high, and this technique is very difficult to scale up to million, for example, because you still need to embed these reflector inside the glasses. Actually, this technique used a lot for product in military. It works very well, but the problem is the cost for large scale. The other technique, it's called reflective technique. So you have here Epson, Google, and Optinvent. So it use reflective mirror, semi-reflective mirror. There is no color issue here. For Google and Epson, they are using, thick light guide. So the light coming here, the collimator is here, reflecting back to the eye. So why they need thick? Because the field of view is proportional to the thickness of the light guide because they have one mirror. In Epson case, they have the same, okay? Is 1 centimeter thick. It means 1 centimeter today with 26 degree. If they would like to have 40 degree, you got very thick light guide. In our case, in Optinvent, instead of having mirror at 45 degree, we flatten the mirror. So we have microstructure here where the mirror are there. So it allows you to use thin light guide while using the same technique. So why light guide technology are really popular today? Because it allows you to have the best form factor for glasses, for smart glasses. Still, there's different, today the main differentiation is performance, cost, and still, for example, here, this technique is really exotic. It means nobody is, we are not using every day producing component for like hologram or like diffraction pattern. So now I'm going to describe some AR product benchmarking that's using all these technology. So I didn't put all the product, just the one that existing today. They are selling, of course, glasses, HoloLens, Epson, Dacry, Vuzix, ODG, Optinvent. So here the price. It's really, you see, 15,000 with software. It's very high. Only 2 products less than 1,000. The rest here is about 3,000. So, in here, the table explains the display performance, if it's AR capable or not. AR capable, for example, Vuzix is not AR capable because it's not transparent, right? So you have also some performance about the CPU, okay? If you have really powerful CPU or not. The sensor, what sensor they have, the user interface, the battery, and it's embedded battery, or it still have some wire and the battery outside the glasses. So what that shows? It shows that there is a lot of variation in price. So there's still price issue. There's still also battery lifetime issue and form factor issue. It means there's still a lot of work to do, but there's still minimum viable product here that people are using today, mainly in the industry. I think I could answer later the question about this slide. I would like to talk about the user interface for AR product today. So we believe the user interface is the key success factor. So what we have today, if you look for all these devices, you have first touchpad. This is virtual keyboard. And you could also have something on your smartphone that control the glasses, right? So this works. However, if you consider somebody working in the industry, they have a glove, they cannot use touchpad. And it's not straightforward to all time use these devices. So you could also have voice command, means there's a microphone in the glasses. The problem is very easy to have online voice command because you could, let's say, you could connect to the web and analyze the voice. However, if it's online, you need really good software in order to allow you to avoid false command here. You need also some noise cancellation, and for that you need two embedded microphone. So the voice command is still not really perfect today, and even in some area in the industry you cannot use it because it's too noisy, right? You could use also gyroscopic. Since all these glasses, they have 9-axis sensor, if you move your head, you could use this to interact with the device. So the problem is not easy. We try it actually. You do it 5 minutes, but you cannot do it all time. Maybe there is social acceptability issue because if you see somebody doing this all time, it's not acceptable. So you have other way to interact with the glasses, which is famous today, camera gesture recognition. You have time-of-flight camera that really track your hand. The problem is, if you try to put your hand like this 5 minutes, you will get tired. So this is not easy too. And also, it implies all time to have a camera running. So you have a CPU, you have a software, you have power consumption. We don't believe this is really compelling for large implementation of these devices. My preference is visual eye tracking. So there is some work done today. There's a lot of interesting interface by imaging and tracking the eye pupil. Actually, they are tracking the eye and the pupil position with the software. They are able to see where your eye is looking very precisely. However, it's very difficult to click in something, right? So this is something we believe will be a good user interface. Now we don't know if really the eye could have a fatigue if you try all time to interact with the display, okay? But we believe this will be a good solution for the future. Today, I see Israeli company. They have something here in the hand, and by moving your hand, you could really enter something. This is very interesting. So people are inventing. There's still way for inventing new way to interact with the display. Now, what we believe the future trend in AR headset and smart glasses, maybe these are personal, but we believe that today AR is to replace the VR in long term. Why? Because if the display could be transparent, it should be transparent, right? The VR experience, you live in another world, you could see 360, but there's no reason why we should isolate ourselves from the world, and even couldn't move, could stand So this is, we know that big company, they have VR, they are creating R&D in AR because this is the future. For the form factor, we work a lot in our company in this subject, and we believe the form factors may be not necessarily a glass, right? I will show you some example because you need to have better comfort when using these devices, and you need also to have better social acceptability. When you wear something, you have to I mean, if you are working in a company, it's not a problem, but if you go on the street, it's not easy to wear something like not looks like normal glasses. So on the technology side, the trend today is to have higher field of view. It's not only a fashion, but it's a way to have larger content, especially in some application like medical or in some gaming, and also to have what we call light field display. What light field is to be able to focus in different distance. Today, when you wear the glasses, you see a plan that is located at one distance. The idea is to display the content, to display in different location in real time, as our eyes look to the world today. So this is actually what, for example, Magic Leap is working on as other company. We too. The trend also for the display is to have really small footprint, and we believe this will be done with light guide based technology, not with others technology that I explained. So we also need better computing platform. It means up to now we are using in smart glasses, all the components we use it are coming from the smart phone industry, including camera, CPU, all these. So we need really something more dedicated to the use in a small place with low heating and also with low power consumption. This is key. This is why we need more hardware integration even more than what we have today in the smartphone. And also we need for a better battery. I don't have personally information what's going on today, but I think we met some people from Panasonic, for example. They try really to reduce the battery size. For the user interface and software side, I think here there's big value because, you could generate a lot of business. We need really to create a new ecosystem to allow people to create a new application on these devices, like what's happened with the mobile phone business. Now I give you an example of what, for example, what we talk about when we need another form factor for the device. This is what Optinvent is working on. It's an example of disruptive AR concept for B2C, a product called OraX, and dedicated to entertainment. So everybody knows the headphones. We have actually a prototype working here. So the headphones is the way to allow people to really get music, but with this device you could have music. Okay. Okay, thank you, Kevin. So you could have a music, and at the same time you could see image here. So you could see a video clip. You could connect to the web, see a film on YouTube.
You're definitely too old.
Sorry? Sorry?
Definitely too old to wear those.
Okay. Yes. So yeah, this is this for us innovation not only in the technology side, in the way we think the product will be. Everybody now they have these big things, and nobody is looking for the consumer. But today, the message is here, we have solution for consumer. You don't need to have very large field of view. This tiny arm provide you everything. Android is there. You have the CPU, the display, and the battery could be there, and you have very high quality music, okay? So this is an example of something we could do today with the technology to creating product for the consumer. Now I'm sorry to switch from consumer to industrial case. These are, I would like to share with you just two use cases we use it actually by our customers. So for industry,
Take it for another comment.
okay, okay, okay. Just have a few slides. So here, what people need in the industry, they need hands-free and need to display the information very close to the eye. So, so this is the need. Some application, they could really use tablet or something else. So our experience already showed that people, there is a huge market for industry. However, the market is slow. And following Deloitte consulting, the market really could surpass the consumer. What people are looking for, what we call return on investment. People don't want to buy 200 or 1,000 units if they are not sure if they implement a solution, they got really the investment back. So the field are really wide, warehouse, maintenance, logistic. I give you two examples of, this is Bosch Rexroth. They have application called Active Glass. Actually, they're very simple. They have a joystick for agriculture machine. And to assemble the joysticks, they need very precise indication. So they start using smart glasses. And with this, they show you the result of their investigation. So they have 50% time saving. They reduce, the 80% of administrative tasks. They have no paper to fill, and they have 100% traceability. And, so this is an example of use today. Another example in training for industry, this is this company is distributing gas. So they have to train operator how to assemble 2 tubes of gas. When the guy is assembling this, he have information here to tell him what he has to do. And when he finish, you could record what he did, and the trainer could explain what he did good or bad. So finally, this is what we are offering as a company. We have 2 products, the Aura 2, and this one is new, which should be available this summer. This is a cap, security cap. Again, why we did this? Because we see that people need ergonomic. We don't need something on the nose. And actually, people are wearing this. So the idea is to have this, to clip it to the cap, and to have a battery that could work more than 1 day. I finished. Thank you very much. I'm open to answer any question. Yes, go ahead.
So there's another type of display, I don't think he mentioned, it's called retina display. So it projects to your eye directly, like outcome. What do you think about that type of
The direct display, yeah, good idea, but today it's very difficult to have a transparent system with it. And the system,
What do you mean transparent system?
sorry?
What do you mean transparent?
Yeah, you could do direct imaging, but if you'd like to have transparency, it's very difficult. Now also there's some technique used by NVIDIA where they're using, let's say, 1 micro lens to cover 8 pixels. So you need a very, very high resolution to get good image. But this good, I mean, people try to reduce the, try to get rid of the optics. This technique you talk about, it means you don't have optics.
We got a question up on the board. If you can, please just put your questions in at slido.com.
This is a question, I'm sorry, performed by the display system. Yes, ophthalmic correction could be. However, all light guide system, all the technology using light guide system, normally the collimation is at infinity. It means you cannot make the correction inside the optical system. You have to do it after the light guide. You have some freedom, but you cannot cover myopia from -5 to +5. So, yeah, the answer is yes for some system, but not for the light guide technology.
Fantastic presentation. My
you.
name is Lex. I've been looking forward to this for the whole conference, and you delivered it beautifully. Thank you. You're doing something that some of these major players like Microsoft, ODG are not doing, right? You're focusing on comfort, focusing not on putting the weight of the device on the bridge of the nose. Why did that happen? Why is that you are the only space? Why do you think the bigger players are not using this? Seems so practical, right? And so much more comfortable, especially for industrial applications, right?
I think, yeah, how to answer your question. I think this is based in experience. The problem when you have all the optical system here is it's heavy, and all the heating in this area also. So I think everybody is improving. I'm not saying that this is bad. People try. But you cannot really, how to say, you cannot really, the current form factor is not satisfactory, because we are here in AWE, you are running demo. But if you give these lenses, these to operator working 8 hours with it, no way. A lot of heat, a lot of weight. So if the customer couldn't accept them, it means there's failure. So this is why the form factor, the ergonomy for us is the first factor. So we'll see.
Okay, and there's one last question. Can download the slides, please? Thanks for a nice presentation.
Yes, no problem. If you have any other question, you can send me an email. Thank you very much for your attention.
Thank you very much.